There's a rule in physics that says the universe is never allowed to show you this. And one object in space might be breaking it right now. Here's the rule. Every black hole is supposed to wear a disguise. It's called an event horizon, the invisible boundary where gravity gets so strong not even light can escape. That boundary isn't the black hole. It's the clothing. The thing underneath. The actual black hole is a singularity, a point where matter gets crushed down to zero size and infinite density, where the laws of physics, as we know them, simply stop working. Nobody has ever seen one directly, and physicists built an entire idea around why. The cosmic censorship conjecture, proposed by the physicist Roger Penrose in 1969, it basically says nature is modest. Every singularity in the universe gets dressed. Every single one gets hidden behind an event horizon, forever out of view, protecting the rest of the universe from whatever happens at that point of infinite density. For decades, this idea held. Every black hole we've ever modeled, every one general relativity predicts, comes wrapped in a horizon. It felt less like a coincidence and more like a law. But there's a loophole, and it comes from something black holes almost always do: spin. Real black holes aren't static. They rotate, some of them incredibly fast, dragging space and time around with them. In general relativity, a spinning black hole is described by something called a Kerr solution, named after the mathematician who solved Einstein's equations for a rotating mass. And in that solution, the size of the event horizon depends on two things: the black hole's mass and how fast it's spinning. Here's where it gets strange. The faster the spin, the smaller the horizon gets. Push the spin high enough, past a very specific threshold where the rotation energy essentially equals the mass, and the math does something unsettling. The event horizon shrinks all the way down to nothing. It doesn't just get small, it disappears completely. No validity, no these guys, just the singularity sitting there, fully exposed to the rest of the universe. That's a naked singularity. And here's the part that should genuinely unsettle you. General relativity doesn't forbid it. The equations allow it. Nothing in the math says this can't happen. Physicists just don't know whether nature actually allows a real black hole to spin that fast, or whether something always intervenes at the last second to stop it. Some researchers have proposed a way it could happen almost by accident. Imagine a black hole that's already spinning close to that critical limit. Now drop matter into it in just the right way. Matter carrying enough angular momentum. In theory, that extra spin could push the black hole over the edge, past the point where a horizon can exist at all. It's called the Penrose process, taken to its extreme, and thought experiments like this are exactly why the censorship conjecture has never been fully proven. It survived every test so far, but nobody has shown it's actually true. So what would a naked singularity even look like if one existed? Not a shadow, not a silhouette, like the black hole images you've seen from the Event Horizon Telescope. A visible point, arguably the most extreme object physics allows, where gravity, space, and time break down completely, with nothing standing between it and us. Light from an infinitely dense point, reaching your eyes directly. Astronomers haven't found one. Every black hole we've measured so far appears to spin below that critical limit. Horizon fully intact, secret fully kept. But haven't found one yet, and impossible are very different claims, and physicists are careful not to confuse the two. Some think it's impossible, that nature always finds a way to keep it secret, that some unknown mechanism steps in before a horizon can vanish. Others think we simply haven't looked hard enough or found the right black hole spinning fast enough to catch nature in the act. Either way, this isn't science fiction sitting on a shelf. It's sitting inside Einstein's own equations, unresolved, more than 50 years after Penrose first raised the question, and it's still actively studied by physicists trying to figure out whether a universe has a loophole in one of its most fundamental rules. So next time someone tells you black holes keep their secrets forever, remember, that might just be a rule waiting to be broken. Follow for the next one, because this universe has more loopholes like this than you'd think.